Today's problem comes from the Mandelbrot Competition 2018. Quadrilateral ABCD has side lengths AB equals 6, BC equals 7, CD equals 5, and DA equals 4. Point P is situated in ABCD such that the measures of angles APB and CPD are each 90 degrees, and the measure of angle BPC is twice the measure of angle APD. What is the positive difference between the areas of triangles APD and BPC? Okay, so I'll start by representing some side lengths in the figure. Let's represent AP with A, BP with B, CP with C, and DP with D. Let's also find the measures of angles BPC and APD. Take note that we have two right angles here, and the whole angle is 360 degrees. And so the sum of angles BPC and APD must be 180 degrees. Since this angle is twice the other angle, BPC must be 120 degrees and angle APD must be 60 degrees. Okay, now I will use the formula for the area of a triangle. A equals 1/2 x times y times the sine of angle beta. Okay, because if you notice, the pieces of information that we have right here are sides of triangles and an included angle. For example, in triangle BPC we have the included angle 120 degrees, and for triangle APD we have the included angle 60 degrees. So let's come up with expressions for the areas of these two triangles using this formula. Let's start with triangle APD. So the area of triangle APD is equal to 1/2 times AD times the sine of 60 degrees. Sine 60 degrees is square root of 3 over 2. So this expression simplifies to square root of 3 over 4 AD. Similarly, we can have the area of triangle BPC, and this is equal to 1/2 BC times the sine of 120 degrees, which is also square root of 3 over 2. So this expression simplifies to square root of 3 over 4 BC. Okay, so what we really want is the absolute value of square root of 3 over 4 AD minus the square root of 3 over 4 BC. So this expression represents the positive difference between the areas of triangles APD and BPC. Now we can write this expression as the square root of 3 over 4 times the absolute value of AD minus BC. We just need to find the value of this expression inside, and then we are done, right? But the next question is, how can we come up with some other equations that contain the products AD and BC? This time, I'll use the law of cosines to come up with such equations. But we will use the same triangles BPC and APD. Let's start with triangle APD. By the law of cosine, we have 4 squared equals a squared plus d squared minus 2ad times the cosine of 60 degrees. So this equation simplifies to 16 equals a squared plus d squared, and take note that cosine 60 degrees is just 1/2. So this expression, or this term right here, simplifies to minus AD. So let's set this aside and do the same thing to triangle BPC. Again, by the law of cosine, we have 7 squared equals b squared plus c squared minus 2bc times the cosine of 120 degrees. The cosine of 120 degrees is negative 1 half. So, the equation can be written as 49 equals b squared plus c squared plus bc. Okay, so we have now our two more equations that contain AD and BC. Now, how can we come up with the expression AD minus BC using these two equations? Let's add the two equations. If we do this, we obtain 65 equals a squared plus b squared plus c squared plus d squared minus AD plus BC. Now let's solve for AD minus BC in terms of the other variables and constant. So we have AD minus BC equals a squared plus b squared plus c squared plus d squared minus 65. Okay, the next question now is how can we find the value of a squared plus b squared plus c squared plus d squared? Take note that we still have one more important information that we have not used. If you look at again the figure, we actually have here two right triangles, right? So, if we apply the Pythagorean theorem, we see that a squared plus b squared using this triangle is just 6 squared, right? Similarly, c squared plus d squared using this triangle is just 5 squared. And so, AD minus BC is equal to 36 plus 25 minus 65 or 61 minus 65, and that's negative 4. And this is the value of AD minus BC, which we can substitute here, right? And so the final answer that we want is square root of 3 over 4 times the absolute value of negative 4 equals square root of 3. And so the final answer is square root of 3. That's the positive difference between the areas of triangles APD and BPC.